Hello students, now let's take the next topic, reflection through a plane parallel to coordinate axis or coordinate plane. A plane parallel to coordinate plane is here. Plane parallel to coordinate plane. We have to reflect an object through this one. Now let us write the question for that. The question can be asked as, write an algorithm to reflect object x through plane z equal to k. So step 1 here, step 1, consider plane z equal to k which is parallel to the plane z equal to 0, that is xy plane. We will make it coincident with the same xy plane to whom it is parallel. We will make coincident with xy plane by translating it in z direction by minus k units. Okay, using the transformation matrix is what that time? Translation, and that matrix will be what? 1 0 0 0 1 0 0 0 1 0 0 0 minus k 1. Okay, now along with plane, the object is also translated. Now step 2, what the step 2 says, well, it will coincide with xy plane, so we can reflect the object through xy plane. We have that from transformation matrix, right? Through xy plane, or that is z equal to 0 plane, and then take back that plane to its original position using inverse translation. So we will get the object is get reflected. Now reflect the object through xy plane, that is z equal to 0 plane, using what is the matrix there? Rz, you know that it is 1 0 0 0 1 0 0 0 0 minus 1 0 0 0 0 1. This is a matrix of reflection through z equal to 0 plane. Step 3, take the plane back to its original position. original position using what the matrix? Inverse translation. And that matrix is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 k 1. This is a matrix here. Therefore, what is step 4? Step 4 is that here. Step 4 is that what? The concatenated. Therefore, the concatenated transformation matrix is, it is T equal to translation into reflection into inverse translation, right? And step 5, it is what? Simply we have to obtain the translated object, that the reflected means what? The transformed object. Apply T on this, the original object X. Now try to understand this thing here. Suppose, let me explain. I am trying to explain. You can visualize it. It will be very clear to you by visualizing. Suppose this is X, Y and Z. Here there is somewhere a plane. Here the point K on Z axis. Now this plane we are taking here, as this K coincides with whom? Origin. This K unit distance will come to this origin. That's why minus K unit we are doing. Okay. Take it back to XY plane. It will be coincident with XY plane. Somewhere here the object is there that time. Okay. And we have to reflect that object. We have to take the image of that object to this side here. Right. So I am taking that one to this point to origin. Then we will, while doing that, that object is also coming here. So now reflect it, the object goes down and then again take back to its original position. So object will be in downward side. So that is a reflection of it. Okay. So here I am just trying to explain it. Similarly, we can write, now here I had written the reflection of an object through a plane Z equal to K. Similarly, I can write it for Y equal to K, for X equal to K also. So let me write them as a note. Note 1. Similarly, we get the concatenated transformation matrix for reflection through plane Y equal to K, that is parallel to Y equal to 0 or XZ plane. Y equal to 0 or XZ plane. That concatenated transformation matrix will be translation, then reflection through Y axis or XZ plane basically, and inverse translation. How can we write that those matrices? It will be 1 0 0 0 0 1 0 0 0 0 1 0, here 0 minus K 0 1. Then reflection. So 1 0 0 0 0 minus 1 0 0 0 0 1 0 0 0 0 1. Okay. Inverse translation. So 1 0 0 0 0 1 0 0 0 0 1 0 0 K 0 1. This one. Okay. Again Note 2 we can write for reflection through plane x equal to k. Also, we get the concatenated transformation matrix for reflection through plane x equal to k, that is parallel to x equal to 0 or yz plane. Parallel to x equal to 0 or yz plane. What does that? T equal to translation, then reflection through x equal to 0 or yz plane into inverse translation. So that is the matrix is this one. Then again this is -1. This is our required matrix here. Now let me take one small example. Find transformation matrix of reflection through y equal to 2.5 plane. Solution. Here y equal to 2.5 plane is parallel to y equal to 0 plane. Therefore, T is what? Translation into reflection through this xz plane or inverse translation. Now translation, what is k here? 2.5. Compare with that one. So 2.5 is a value of k. So what we get? 1 0 0 0 0 minus 2.5 0 1 into 1 0 0 0 0 minus 1 0 0 0 0 1 0 0 0 0 1 and what? Inverse translation. So 1 0 0 0 0 1 0 0 0 0 1 0 0 2.5 0 1. So now product of all these three matrices is nothing but we want the same one, and the product is 1 0 0 0 0 minus 1 0 0 0 0 1 0 0 5 0 1. You can check that product. Take product of these two or either these two, then that one with this. Whatever you want, you can do that. Okay. Now the next topic is that reflection through an arbitrary plane. So let me write that. Reflection through an arbitrary plane. This is again an important one. Question. What we can say? Write an algorithm. Write an algorithm for reflection of an object. Reflection of an object X through a plane which passes through a plane which passes through a point A x1 y1 z1 and direction cosines of normal are Cx, Cy, Cz. Okay, so let's write the algorithm for that. Solution. Step 1. Now this is an arbitrary plane which passes through point this, and direction cosines of normal to the plane are given. Normal is nothing but perpendicular to the plane. There are many normals to the single plane are there, infinitely many are there. So consider the given plane which passes through, the point A having coordinates x1, y1, z1 and direction cosines of normal are what? Cx, Cy, Cz. Okay. Now first we translate point A to origin. Using means what? A point is on that arbitrary plane, but first of all we will translate that point to origin so that the plane will passing through origin using the translation matrix, and that translation matrix is what here? 1 0 0 0 0 1 0 0 0 0 1 0 minus x1 minus y1 minus z1 and 1. This is our matrix of translation here. Because of this translation, a plane passes through origin now. Plane passes through what? Origin. Along with the plane, object is also what? Translated. Right? Now step 2. What the step 2 says? Step 2 is just like our rotation through an arbitrary line. Similar algorithm is much similar to that one because we are using the direction cosines of normal to the plane. Normal is nothing but the line. Yes. Now this plane passing through origin, so we can take the normal to this plane which is parallel to the given normal which passing through origin, and that normal having the same direction cosines because the parallel lines having the same direction cosines as well as direction ratios. So step 2, we make the plane coincident with xy plane. Make the plane coincident with xy plane. For this, we rotate it about x-axis through an angle alpha, and then about y-axis through an angle what? Beta is there. For this, we use the normal to the plane. Normal to the plane passing through origin. Passing through origin. Now same kind here. So first, to find alpha, what here we have to do? This xyz plane, right? So here somewhere here the point P having the coordinates cx, cy, cz, which is on a line passing through origin. That's why these are direction cosines of normal to that one. This distance is what? 1. Yes. Now we have been projected it on yz plane. We get the point P dash having these coordinates, right? Now this distance is what? D. This is what? cy, and this is what? cz, right? So here this angle is what? Alpha. This is also cz here. As such also we can take, right? Now consider normal through origin. OP bar is unit vector. Therefore, P is what? Cx, cy, cz. Therefore, to find angle alpha, we take its projection. We take its projection on yz plane, which is point P dash 0 cy cz. Okay. Also, length of OP dash is what? D. Angle P dash OM is what? Alpha, right? What is D? D is under root cy square plus cz square. Cos of alpha is what? Cz upon D. Sin of alpha is cy upon D. Therefore, the matrix for this rotation, the matrix is what? It is through x-axis. So 1, 0, 0, 0, 0, cos alpha, sin alpha, 0, 0, minus sin alpha, cos alpha, 0, 0, 0, 1, and that is same as what it is. It is equivalent to 1 0 0 0 0 Cz upon d Cy upon d 0 0 minus Cy upon d Cz upon d 0 0 0 0 1, right? This is our matrix of rotation there. Now next part is what? To find beta. Now you know, to find beta, that vector will come on this xz plane. This is why this plane, xz plane. So here the point P will be there. Is this much distance is how much? Cx, you know, this is d, and this is what? 1 here. So here we rotate. This angle is what? Beta here, right? So we rotate OP bar about y-axis through an angle beta. Therefore, angle PON is what? Beta. Okay. Therefore, cos of beta is equal to D, sin of beta equal to Cx, but it is negative 3D rotation. Yes, negative 3D rotation. Therefore, what is Ry, or the rotation through y-axis? Is what does that? It will be cos of minus beta 0 minus sin of minus beta, right? 0. Then 0 1 0 0. Here sin of minus beta 0, cos of minus beta 0 0 0 0 1 is this. And that is same as what? It will be d 0, this minus minus becomes plus, so Cx 0. Next 0 1 0 0. Here it will be minus Cx 0 d 0 0 0 0 1. Fine. This is a matrix of rotation. Now step 3. What the step 3 says? Now we have been make it coincident with xy plane, that is z equal to 0 plane. So we will reflect the object through z equal to 0 plane. Now plane is coincident with z equal to 0 plane. Therefore, reflect the object through z equal to 0 plane using that matrix of reflection is, that matrix will be, suppose reflection 1 0 0 0 0 1 0 0 0 0 minus 1 0, reflection through z equal to 0 plane 0 0 0 1. This is a matrix of reflection here. Now step 4. After reflection, now we have to take back to its original position. So for that, whatever transformations we have did before reflection, we have to do the inverses of them. So now we take the plane back to its original position. Using this Ry inverse, Rx inverse and inverse translation respectively. Okay, therefore the concatenated transformation matrix is T equal to what? Translation into rotation through X, rotation through Y, then reflection, then inverse rotation through Y, inverse rotation through X, and then inverse translation. You know, in inverse translation, just wherever the translation factor is negative, then we have to make it positive. While for inverse rotation matrix, we have to take a transpose of this rotation matrix. Simply that one we have to take and take a multiplication. Already we have taken that part in chapter 1. What are the inverses of inverse transformations? And at last we have to get x star, that is what? X into t. Now let me take a small example here so that this topic will be clear to you. So example, find the concatenated transformation matrix required to make the plane x plus y plus z equal to 0 coincident with z equal to 0 plane. Now here one thing try to memorize. Here the basic equation of plane, let me write the solution. The equation of plane can be written as equation of plane in general is what? Ax plus by plus cz plus d equal to 0. If d is 0, then that plane passing through origin. So here it passing through origin. Fine. Okay. And what are these? Where these A, B and C are direction ratios of normal to the plane. So this part you should memorize first. Later on compare with that. Now here given plane, what does that? X plus y plus z equal to 0. Passing through origin. As d is equal to what? 0. And direction ratios of normal to that plane, normal to it, are what? 1, 1, 1. Therefore, direction cosines of normal are 1 by root 3, 1 by root 3 and 1 by root 3, right? Therefore, we get Cx equal to 1 by root 3, Cy equal to 1 by root 3 and Cz is also what? 1 by root 3. Fine. Therefore, what is D? Therefore, D is under root Cy square plus Cz square, and that is nothing but root 1 by 3 plus 1 by 3. So it will be root 2 by root 3. Right? Now to find alpha, what is cos of alpha? Cos of alpha is 1 by root 2. Actually, it is cos of alpha is Cz upon D and sin of alpha is Cy upon D, right? And sin alpha Cy upon D, that is also what? 1 by root 2. So both of these gives us alpha is how much? 45 degree. Okay, alpha will be 45 degree, right? Now to find beta. Now here basically according to question we have to find the concatenated transformation matrix to make this plane coincident with z equal to 0 plane. So for that we need these angles also, but if we found these values simply, then also we can put them in a matrices. So here cos of beta is what? It is D, and that is root 2 by root 3, and sin beta is what? Cx, and that will be 1 by root 3. Okay, there, that gives beta is how much? 35.26 degree. But we will take minus beta while doing a calculation. Now we want a concatenated transformation matrix. Therefore, the concatenated transformation matrix is concatenated transformation matrix T equal to what is here? That concatenated transformation matrix is simply rotation through x through an angle alpha and rotation through y through an angle what? Minus beta. This one we have to find out. So these matrices are nothing but, what are they? Let me write. This 1 0 0 0, this is 0 cos of alpha sin of alpha, 0 0 minus sin alpha cos alpha, 0 0 0 0 1, right? Into what is here? Here cos of minus beta, so it will become cos beta, 0 minus sin of minus beta, so sin of beta, 0, right? 0 1 0 0. Then next here sin of minus beta, so minus sin beta, 0 cos of beta, 0 0 0 0 1. Now put the values of cos alpha sin alpha, cos beta sin beta from the problem and take a multiplication of these matrices. So we get 1 0 0 0 0. What is cos alpha? 1 by root 2. This is 1 by root 2. 0 0 minus 1 by root 2, 1 by root 2, 0 0 0 0 1. Again here cos of beta is root 2 by root 3, 0 1 by root 3, 0, right? Then 0 1 0 0, here minus 1 by root 3, 0 root 2 by root 3, 0 0 0 0 1. and the product of them will give us the matrix root 2 by root 3, 0, 1 by root 3, 0. Then minus 1 by root 6, 1 by root 2, 1 by root 3, 0. Minus 1 by root 6, minus 1 by root 2, 1 by root 3, 0. 0, 0, 0, 1. This is our required concatenated transformation matrix for this, for making this plane coincident with z equal to 0 plane. So here we will stop for this video. In next video we will see affine and perspective transformation. Okay, so thank you.